Welcome back to Backspace Academy. In this lecture, we'll have a look at the compute and networking services of AWS. We'll then have a look at some examples, and finally, we'll finish up with a hands-on lab where we're going to deploy a WordPress web server using the Amazon EC2 service. Amazon Elastic Compute Cloud, or EC2 for short, provides virtual servers in the AWS cloud. You can launch one or thousands of instances simultaneously and only pay for what you use. There's a broad range of instance types with varying compute and memory capabilities, and those will be optimized for different use cases. Amazon EC2 autoscaling allows you to dynamically scale your Amazon EC2 capacity up or down automatically according to conditions that you define. It can scale up or down by launching or terminating instances based on demand. It can also perform health checks on those instances and replace them when they become unhealthy. Amazon Lightsail, it's the easiest way to launch virtual servers running applications in the AWS cloud. AWS will provision everything you need, including DNS management and storage, to get you up and running as quickly as possible. Amazon Elastic Container Service, or ECS for short, is a highly scalable, high-performance container management service for Docker containers. The containers, they will run on a managed cluster of EC2 instances. AWS Lambda is a serverless service and lets you run code in the AWS cloud without having to worry about provisioning or managing that service. You just upload your code and AWS takes care of everything for you. So let's have a look at how we could use these services to deploy a web server in the AWS cloud. Here we have the AWS cloud and our virtual private cloud, or VPC, located inside that. And remember, a VPC is our own private space within the AWS cloud, and no one can enter that unless we allow them to enter it. We can launch an EC2 instance, and that can be running our web application, for example, WordPress. So what happens if this single EC2 instance becomes overwhelmed by demand? For example, we might have released a new product and our WordPress application cannot deliver the web pages quickly enough to satisfy that. What we could do is that we could tear down that instance and put in a bigger instance that could handle that demand. And that is called vertical scaling. And that used to be all the rage 10, 20 years ago. But the problem is that it takes time to do that. And while we're doing that, our application is not running. And also, what happens when the demand goes back down again? Do we have to tear that down and then put in a smaller instance? And what happens if that happens every day? What happens if that happens every hour? It's just not going to be economical for us to do that. What we can do is that we can horizontally scale, and we do that by adding more instances. And as demand goes up, we add more instances, and as demand goes down, we terminate those instances. And that way, we still have continuity of our application. Our application will always be running because there's always going to be at least one EC2 instance to look after the demand. One problem with this architecture is that it has multiple endpoints for our web server. And that's not practical because customers are not going to go to one endpoint until that stops working and then go to another one and then another one. It's just not going to work like that. And obviously their bookmarks in their browser are not going to be valid. So we need a way of having one single endpoint for that web application that our customer can go to, and then having a way of distributing those requests to a EC2 instance that is available. That is where elastic load balancing comes in. So it can receive traffic from our end users, and it will distribute that traffic to an EC2 instance that is available. So a request will come in, it will distribute it to an available EC2 instance. Another request will come in and it will distribute it to a different EC2 instance that is available, and it will balance the load across those EC2 instances. And if one of those EC2 instances become unhealthy, it will fail a health check with the Elastic Load Balancer. And then the Elastic Load Balancer will no longer send traffic to that unhealthy EC2 instance. But what happens if that demand is only for a short period of time, for example, half an hour? What do we do then? It's not going to be practical for us to terminate instances when demand goes down and then launch instances manually when that occurs. We can't do that every hour. It's not going to be practical. And that's where the auto-scaling service comes in. It can launch EC2 instances automatically when the demand on those instances increases, and it can terminate automatically EC2 instances when the demand on those instances goes down. It can also perform health checks on those instances, and if one of those instances becomes unhealthy for whatever reason, it can replace that instance with a healthy instance, and it will do that automatically without you having to do anything at all. So now we'll have a look at the networking and content delivery services. Amazon CloudFront is a global content delivery network, or CDN for short, that securely delivers your frequently requested content to over 100 edge locations across the globe. And by doing this, it achieves low latency and high transfer speeds for your end users. It also provides protection against DDoS attacks. Amazon Virtual Private Cloud, or VPC for short, lets you provision a logically isolated section of the AWS cloud. And you can launch AWS resources in that virtual network that you yourself define. And this is your own personal private space within the AWS cloud, and no one can enter it unless you allow them to enter it. AWS Direct Connect is a high-speed, dedicated network connection to AWS. Enterprises can use it to establish a private connection to the AWS cloud in situations where a standard internet connection won't be adequate. AWS Elastic Load Balancing, or ELB for short, automatically distributes incoming traffic for your application across multiple EC2 instances and also in multiple availability zones. So if one availability zone goes down, the traffic will still go to the other availability zone, and your application will continue to deliver responses to requests. It also allows you to achieve high availability and fault tolerance by distributing traffic evenly amongst those instances, and it can also bypass unhealthy instances. Amazon Route 53 is a highly available and scalable domain name system, or DNS for short, and it can handle direct traffic for your domain name and direct that traffic to your back-end web server. Amazon API Gateway is a fully managed service that makes it easy for developers to create and deploy secure application programming interfaces, or APIs, at any scale. It handles all of the tasks involved in accepting and processing up to hundreds of thousands of concurrent API calls. It's a serverless service, and as such, you don't need to worry about the underlying infrastructure. AWS looks after everything for you. So let's have a look at an example of how we can use these networking services of AWS. So here we've got the architecture that we looked at before in the compute section, but one thing we didn't mention was availability zones. So let's just say that we've launched that architecture in a single availability zone. What happens if that availability zone goes down? What happens to our traffic? Our traffic has nowhere to go, and our application stops delivering responses to requests. That is why it's always desirable to have our architecture distributed across multiple availability zones. That way, if one availability zone goes down, the other one will continue to operate and the infrastructure within that other availability zone will continue to respond to requests. We can launch EC2 instances in multiple availability zones, and our elastic load balancing service can distribute that traffic across multiple availability zones as well. So if one availability zone goes down, the elastic load balancer will continue to distribute traffic to the availability zone that is still healthy and to those instances in that availability zone that are still healthy as well. So let's just say our application running on these EC2 instances is a WordPress web server, and that contains lots of images and lots of video that is static content. It's not really changing that much, and it's not efficient for us to continue to keep delivering that from our EC2 instances. We would like somewhere to put that where it can be delivered with high speed and low latency and to take the load off our EC2 instances. That is where the CloudFront Content Delivery Network, or CDN, comes in. So we can get these large images and large videos that are not really changing that often, and we can put that in a CloudFront distribution. And CloudFront will cache that and distribute that across hundreds of edge locations across the globe. So when your end user requests that video or those images, it will be delivered to them with really high speed and low latency. And at the same time, it's going to take the load off your EC2 instances and is going to significantly reduce your costs. At the same time, dynamic content that is changing regularly, CloudFront can forward those requests over to the elastic load balancer, which will then forward them to an EC2 instance. So that way you have the best of both worlds. You have dynamic content delivered as a dynamic content, and at the same time, you have these large videos and images that aren't really changing that often, delivered very rapidly. Now that CloudFront service or that CloudFront distribution will have its own DNS name that we can put into a browser and we can directly access that. The problem with that is that that DNS name for that CloudFront distribution will be something very complicated and just won't mean anything to our end user at all. So we would prefer to have our end user type in a domain name and have the requests for that domain name forwarded to that CloudFront service. As you can see here, we've got example.com, and that is where Route 53 domain name service can come in. So Route 53 will grab those requests for your domain, example.com, and it will forward those requests over to the CloudFront service, and the CloudFront service will handle it from then on. So let's just say we work for a large enterprise that has its own corporate data center. And the reason it's got its own corporate data center is because that is located where the employees work. And we don't want our employees to be slowed down by a network. We want them to be able to work efficiently. But at the same time, we have resources on the AWS cloud that those employees also need to access. So we need some way of having a high-speed connection between our corporate data center and the AWS cloud. And that is where the AWS Direct Connect service comes in. And that can provide a very high-speed fiber optic network between our corporate data center and the AWS cloud. And that is completely private. Okay, so that's a very complicated architecture, and don't be too concerned if that's very overwhelming, because if you're going on to become a cloud practitioner, you're not going to need to really be able to produce this yourself. As an associate level certification, that is a different story. You'd be expected to create this yourself. But Cloud Practitioner, you'll need to know what these services do. You'll need to know that Route 53 will forward requests for your domain name to a back-end endpoint. CloudFront will distribute your content to hundreds of edge locations across the globe. Elastic Load Balancer will receive requests and distribute those requests to multiple instances across multiple availability zones. A virtual private cloud is your private space within the AWS cloud. The AWS Direct Connect is a high-speed fiber optic network connection between an on-premises corporate data center and the AWS cloud. If you understand that, then you're well on your way to passing the Cloud Practitioner exam. Okay, so coming up next, we're going to have a lab. So make sure that you download the Introduction to AWS lab notes that come with this course. So what we're going to do is that we're going to launch an EC2 instance, and we're going to select an Amazon machine image of a WordPress web server. And that will allow us to deploy a WordPress server on the AWS cloud. And then we're going to be able to go to our browser and view our website that was created by that EC2 instance. And we're going to do that all through the AWS Management Console on our desktop computer. Okay, before we start the lab, need to make sure you get your hands on these lab notes. The section we're going through here is the creating a web server with EC2. If you run into trouble when you're following the lab notes, there is a troubleshooting section here, troubleshooting viewing your WordPress application. And also there is a troubleshooting logging into your WordPress application. So make sure that you follow these lab notes, and if you get into trouble, follow the troubleshooting steps. So starting off in the Management Console, we're going to go to Services and then EC2. So I've got this in the A to Z, and just scroll down to EC2. And what we're going to do is go into instances here on the left, and we're going to be creating an instance or launching an instance. Now you won't have any instances here. I've got an old one here, but yours will most probably be empty. We'll click on Launch Instances. And what we're going to do is go into the AWS Marketplace here on the left, and we're going to search for WordPress. And we're going to get the WordPress certified by Bitnami and Automatic. So we'll select that one. And it's going to show the hourly fees. So for software, there's nothing. This is open source software, so there's no cost there. But if we select a T2 Micro, the costs there are 12 or 1.2 cents per hour. But because we're going to be operating under the free tier with a new account, which is less than 12 months old, then you will not be paying for that. But my account here is many years old, so I have to pay for it. But you will be operating under the free tier if you have a new account. We'll just click on Continue. And we'll select that T2 Micro, which is again free tier eligible. So there we can see micro instances are eligible for the AWS free tier for the first 12 months following your AWS sign up date. So next we go to Configure Instance Details. Now the main thing that we're looking at here is to make sure that we have a public IP enabled. So we click on Enable here, and that assigns a public IP. So that means that we can actually find this, this web server over the internet using our browser. And we're going to launch that into our default VPC. We'll click on Next, Add Storage. We'll leave the storage as it is. Now we can add a tag. So we're going to add a name tag. So we can see here, choose your add tag button, or you can click to add a name tag. So I'm just going to click to add a name tag. And so you can see here, it's put the key in already, which is name, and name always has to have a capital N for that tag. And I'm just going to call this Backspace Lab. Okay, and we'll click on Configure Security Group. Now this is already going to create a security group for us. Now a security group is like a firewall. So same as we would have a Windows firewall or a Linux firewall, we have a security group which we can associate with this server, and that will block access to that server, and we need to allow access by using rules. So here we can see we've got HTTP access is allowed, and it's allowed from anywhere here. So we click on this and it'll have anywhere there. And so that's fine. So that will allow us to connect in or to access this, this server on using HTTP in our browser. Next we'll click on Review and Launch. That looks all fine there, and we'll just click on Launch. Now we don't need to choose a key pair, so we just proceed without a key pair. What a key pair allows us to do is to connect in remotely to the Linux operating system of this server. We don't need to do that. All that we need to do is to be able to access the WordPress application that's running on this server, and we'll do that using a username and password. So we don't need to worry about that key pair, and we'll click on Launch Instances. Okay, so that launch process has started. If we scroll down here, there'll be a button on the right-hand side for viewing the instances. And there we go. So there we can see our backspace WordPress lab. We gave it that name tag, and that name tag has come up there. And so that's how we can find that. And that is currently pending, and now it's gone to running, and it will be doing some status checks now. So we need to make sure that those status checks have been finished. And from that point onwards, we will be able to actually access this server. So if we just click on this button up here, this refresh button, we'll be able to see what's going on there. And so there we can see the status is initializing, so it's still got a little bit of a way to go. So we'll give that a bit of time. Okay, so after about 5 minutes or so, our status checks have changed to 2 out of 2 checks have passed. And again, just click on the refresh button there and you'll be able to see it if it's not there. So what we can do now is click on this instance ID to open it up and have a look at it. So there we have our instance ID. It's running. It's a T2 micro instance, and it has this public IP address. It also has a public DNS there, so a public address name there that's we're not going to use as such, but we could also put that into our browser and open that as well. And it has a VPC ID. So we launched this into the default VPC, which has been automatically created by AWS when we create our AWS account. But we can also, if we wanted to, create multiple VPCs and put and use those to launch our instances into. But for this one, I'm just using the default VPC that has been created for us by AWS. We also have a private IP address, and so that is for internal traffic within our VPC there. And we have a subnet ID, which is a subnet within our VPC where this is located. We scroll down here, we can see we've got security, and we can see here that we've got our rule that allows traffic from anywhere on port 80, which is our HTTP access. And that is the rules within our security group. And again, remember, this security group is a firewall that we associate with an instance. And that will prevent access to that instance unless we have rules, which we have defined here, that allow that access to come through. Okay, so what we'll do now is it will try and access our web server. So we can use one of these. We can use this one here if we wanted to. But I'm just going to use this one here, and I'm just going to open that in a new tab. And there we go. So there is our out-of-the-box WordPress website all up and running. So what we'd like to do now is that we'd like to log into our website as an administrator of our website and be able to change this, to be able to put pictures in it and do whatever we want to it. So what we would do is that we will go to / and then admin, and that will take us to our login. So what is this login? We need to have a login to log into our website. So we go back to our instance details. We'll click on instances here. We'll select that backspace WordPress lab again, and we're going to go to actions, and we're going to go to instance settings, and then we're going to get the system log. Now, what this system log is basically what is consoled out. So what would be outputted from a console screen that is recorded in a log by the instance. So if we scroll up here, there will be a console output that will say what our username and password that has been generated for this site is. So we scroll up a little bit more, and there we can see setting Bitnami application password to that, and the default application username is user. So if I copy that password, and if I log in with user, I'll paste in that password and log in. And there we can see we've logged in as an administrator to our WordPress site. Now, one thing I've experienced with this lab with a lot of students is that instead of going through this process of clicking on admin or doing /admin and then putting the username and password, they're going to the instance and they're actually selecting actions and then connect because they're not reading the lab notes. You won't be able to connect. That is to connect in to the Linux operating system using SSH with a remote computer. And we won't be allowed to do that because when we launched this server, we were asked whether we wanted to associate an encryption key pair to this server, and we said no, because we're not going to be connecting into the Linux operating system. All we're doing is we're going to be accessing our WordPress application, and that's all that we need to do. So if you find that is a problem, that is what's most probably it if you cannot get this connected in. The other things there is that there is also a troubleshooting of launching as well. So troubleshooting viewing your WordPress application, most probably is that something has gone wrong with the firewall setting, that it doesn't have that port 80 access in there as well. But if you follow the lab notes, you won't get into trouble. So what we'll do now is we will clean all this up because we won't want to get billed for it, although you won't get billed for it if you're on the free tier. If you leave it here and then you launch another instance and you've got two of them, you will be billed for one of those. So let's make sure that we clean this up. So we'll go to actions and we go to instance state and we go to terminate instance and we'll terminate. Successfully terminated. So that process will be chugging away. And again, we can click on this refresh button and see when it has actually changed from shutting down to terminated. So that brings us to the end of a very quick lab. So you've now launched a web server and you've accessed that. And I hope you got a lot out of it. And I look forward to seeing you in the next one.